love physics so much. I really love physics. Yeah!
Good afternoon, everyone. This is our first podcast, and to start off, we will introduce ourselves. My name is Casey.
I'm Ian.
I'm Jack.
And I'm Thomas.
And right now, we're going to start off with our first topic, energy production.
All right. So this is a constantly changing field with a lot of new discoveries and a lot of new news coming from it pretty much every day. So we have a few articles here if anyone would like to share.
Well, before we get into the articles, I'd just like to add something about energy production that I hadn't thought about that much recently. I was talking to Casey the other day about how energy production just wasn't really a field that I was very interested in because I didn't feel like there was anything like groundbreaking within it that really affected the human race. But he made a great point that like energy production is kind of the future of the human race. Would you like to elaborate on that a little bit, Casey?
Yes, what I was saying is that humans have to rely or do rely on energy, and energy usage will just increase over the years as our population will peak at 9 billion towards 2030, and this will increase our need for energy. So the point you made about how energy production doesn't seem that interesting, I would say, is quite wrong. Ian, do you want to share those articles?
Yeah. All right. Well, I'm up here on the first article, and it's talking about the long wait for fusion power may be coming to an end is the title of this. This is on NBC News, and it's saying some experts think that commercial fusion reactors could begin operation as soon as 2030. What do you think that really means for our society, Ian?
Haven't they been saying that we're really close to fusion for a very, very long time now?
Yeah, Thomas, what do you think?
I think that it's kind of far-fetched, but I believe that if they were able to do it, it would be an incredible leap towards the future, and we would probably be able to sustain ourselves a lot longer.
Well, yeah, like, I think fusion's much better than fission. Obviously, I don't think any of us really want to or have anything different to say about that. I mean, there's like less waste in general, and there's more energy produced in fusion than in fission. But yeah. I don't know how realistic this is.
Yeah, I mean, I'm here on the article, and they're calling the reactor the ITER reactor. I don't know what that stands for. Can't find it here. But basically, they're saying here that it's on track to achieve nuclear fusion operation in the mid to late 2040s. So even later in the article, there's kind of a contradiction that it may take a decade or and a half longer than expected. And to quote the article, it says, the decades needed to bring the ITER reactor to full operation reflect the huge engineering challenges still facing fusion researchers. So it doesn't seem that they have any definitive proof that they're going to be able to get this reactor set up and going in a few decades. They just hypothesize, I guess, that the technology will be there then, which obviously is a little bit far-fetched.
I don't know. I think with Ian's point about the fact that we have been quote unquote 50 years from making a fusion reactor, this one just seems to kind of support that idea that, oh, we're 50 years away from fusion power. If only we just get that one problem. It seems I would agree that it seems kind of far-fetched, but we are approaching. We are technologically expanding, and as through the years, I definitely have some hope for this fusion reactor.
Yeah, what do you guys think? It says in the article that the ITER reaction is going to be built in southeastern France, and right now France is pretty big into nuclear power, and although some of their civilians are really not into this. I don't know what you think about the fact that France is now leading the construction of a fusion reactor in Europe.
Well, I believe that a lot of other European countries are going to see this and they're going to think, what can we do to kind of do our part in the progression of energy production. And I mean, like, you look at Europe, and there's a bunch of European countries that are really leading the way in energy sources and energy production that's renewable and basically is straying away from the fossil fuels model that the US has kind of been following for a very long time. And I'm curious to know when the US is going to catch up, because I mean, I'm sure the US has kind of always considered itself to be at the front of a lot of these movements, but here it seems that we are falling quite far behind.
Exactly. The U.S. has been falling behind on these renewable resources because we haven't done any kind of plan to invest in solar or wind. There has been efforts, of course, but it hasn't been substantial enough to consider these energy sources as anywhere close to the level of infrastructure we have for coal, natural gas, and oil, even though these resources will run out within our own lifetimes, which is quite disappointing.
Yeah, it's frighteningly close. I mean,
I was going to agree with Casey and say, like, yeah, there has been some efforts, but they haven't really been widespread, and most of our efforts are mainly going towards oil. Like, most of our funding is going towards oil and figuring out ways to, like, lengthen, or like, not, it's probably not the best word, but
yeah, but
like, keep the oil lasting as long as we can. So,
yeah, I mean,
we'll do things like fractional distillation, or
yeah. And there always is the argument that, I mean, we can't just like make the change like that to renewables. You know, there obviously is going to have to be some kind of transitioning, but I just don't think the rate at which we're transitioning to renewables is fast enough to make up for the impending end of fossil fuels.
Yeah, I totally agree.
I mean, like, all right, like, we're really not transitioning though, because we're still putting all of our funding into fossil fuels.
No, we are, but I mean, you look, we definitely have a lot more renewable energy sources now than we did 20 years ago.
Mm-hmm.
That's true, I guess, but most of it's nuclear, and even then, that's kind of a debatable. Like, most people debate whether that's renewable or like a really good renewable source.
But I mean, even in the immediate area, we have windmills, we have the Bonneville Dam.
I mean, yeah, we get our power from Bonneville, no. That is progress.
I think it also is an interesting point to make that oil, we still use that a lot in the military. Like, oil is used for planes, tanks, and other vehicles. And so that, even though oil will essentially run out within the next 30 to 50 years, it's still an important resource for the military, which we in the United States find very important and put a lot of funding to.
Mm-hmm.
Also, like, to add on to what Casey was saying about oil on like vehicles and stuff, it's on the same article. It's a little further into it, and they're saying they want to put these fusion reactors onto like trucks so that they can like drive the reactors to wherever the energy is actually needed most, or like.
Mm-hmm.
Yeah, and I think that.
I don't know. What do you think of that?
I mean, I think that transitions kind of to the idea of renewable batteries. Thomas, you got something to say about that?
I think like battery technology is a really I mean, if you were able to create a sustainable and actually really good battery, it would be extremely valuable for the future, because storing power is something that we find the need, like a greater and greater need for as time goes on. I don't think that there really is a good option like currently. I think that there's a lot of research being done into it, and I definitely think that it's a huge market that if somebody were to be able to capture the power and be able to sustain it for a long time, I do think that that would be a huge leap forward.
What about in regards to solar and wind, though?
Like, what do you mean? Like in terms of batteries or just in general?
Just
Solar and wind?
batteries, because we already have kind of the methods for it. Just like how do we
How do
take
we
that?
store the
Yeah,
energy?
exactly.
It's like hard to store wind energy though.
No, it is.
Yeah.
I think the only thing that can really compare right now is some of the things where they, if they have excess power from like wind or solar, they pump water up a mountain and then they can get that like some of that energy back. But even those are like pretty inefficient, and I don't think it's anywhere close to what we would need to be completely sustainable and be able to use batteries for actual long-term storage.
Yeah, absolutely. To quote this article from The Hill, it says that there's a prediction of $10.2 trillion being spent on new power generation worldwide through 2040, and 72% of that will be invested in wind and solar plants. So I think it absolutely is very, very important that we look at this battery problem because, I mean, we're looking towards solar and wind energy as kind of a new primary source of energy. I mean, obviously, each of them have their flaws, just as fossil fuels have their flaws. But I mean, 72% of this money will be invested into them. And if we can't efficiently use them, then that money will be spent for no reason. I mean, yeah, it's just like this battery problem is huge. And do you guys know of any actual, like, reasonable attempts at making a battery like this?
Quite honestly, I have no idea, but I think just the main problem always in general is the fluctuation on how much energy you're getting from these resources. Wind is always going to fluctuate, of course, due to wind speeds, and then solar energy is always going to fluctuate due to cloud cover, as the Hill has said. And what about I remember reading about this, like solar energy and like through space, like putting satellites, putting solar panels in space. Like, is there technology going towards that, or money specifically?
Oh, it's definitely possible, I guess.
I mean, it'd be way more faster, but the question also is how are you supposed to transfer all that energy you get from that satellite to Earth?
Yeah, and also another problem, I mean, is like you risk when you put things in space. I mean, you risk, like, never mind. I was going to say something about you risk space debris and like screwing up kind of the whole. I don't know if you guys know more about
Well,
that.
it's funny that you mentioned that because I think this I don't have a definite source on this, but I'm pretty sure that NASA or some other space agency, or in collaboration with other space agencies, keeps track of all the space debris. And I think that it's kind of ridiculous how much space debris there is in orbit around the Earth, and pretty much all the rockets that they send up have to take all that into consideration.
I'm on the article about the space solar panels right now, and I've got a quote from there, and it's saying that if you have them just like at 22,000 miles above Earth, because the sun is already so much brighter there than from the Earth's surface, they'd be able to deliver up to 40 times the annual amount of reliable 24/7 energy
Wow,
that the same cell would be able to generate on Earth.
that's impressive.
But then
it's
don't you
saying-
run into the same problem about like batteries and storage?
Yeah.
Yeah.
Yeah, you would.
Like, it's great to have that much energy, but if you can't transfer that in some way and put it onto Earth, it's essentially useless.
I'm assuming they have a way. I don't know if it's listed here, but they're talking about powering cities because
Oh.
Yeah, I mean, I feel like
They're
there's
saying-
there's plenty of talk of powering cities, but if they can't cite us or they can't say a specific way, like, I don't know. I feel like if it's not explicitly
here's a-
stated, then it means nothing.
Well, I'm looking here. I'm gonna browse this a bit, but there's a specific section here about how they would actually work. So I'll see if there's anything about that in there.
All right. Well, while he's browsing that, do you guys want to take a quick break and hear some physics jokes?
I'm down.
We're gonna have a segment later where we do some try not to laugh physics jokes, but here I think I'll just go over some physics jokes while we're waiting for Ian to arrive on an answer to your question. All right. Are you guys ready?
Yeah.
Are you sure?
Yes. Why did Heisenberg hate driving?
Why?
Because every time he looked at the speedometer, he'd get lost.
What?
I get it.
Do you not get it, Casey? The
No,
Heisenberg
yes.
uncertainty principle.
Oh, it's
So
because
when he knows how fast he's going, he doesn't know where he is.
Ah, okay, I got you. I'm a little slow
Yeah.
on the physics jokes.
Yeah. What do physicists do at football games?
What?
The wave.
Oh,
Wait,
I get
what?
it.
Did you just say go wave?
No, I said the wave. You know what the wave is, Casey?
Oh.
It's not a very good joke.
It's really not.
Anyway.
It's kind of an ambiguous American reference.
Sorry. Forgot you weren't from here, Casey.
Yeah.
All right. Well, I think in the meantime, if you'd like, we can talk about geothermal.
Oh,
I
yeah,
got,
sure.
got the answer.
Oh, you got it. Okay,
Yeah,
cool.
there's a whole section with that very same question, the heading.
Mhm.
So they're saying that in order to transfer the energy, they'll create electromagnetic waves.
Oh.
So
Interesting.
yeah, specifically like microwaves because they carry power, and that's what we use to like heat up our food. Is what the article is saying.
Oh, so they're just going to transmit microwaves from the satellite down to some receiver on Earth?
Yeah, and then that's gonna take it to the grid where it's gonna power up. Like
Yeah, there seems to be a diagram on here too.
Go on there.
yeah, so like it still uses the same like it takes the energy from the photons that the sun emits, and it basically looks like it all hits the solar reflectors, which concentrates the photons,
Mm-hmm.
I see.
and then it's going to send those or transmit those to a different module,
I see.
which will receive the solar energy, and then it converts that. It uses the solar energy, and it converts that energy into a radio frequency, which is then broadcasted down to Earth.
Okay.
I'm just curious about, are there any safety concerns that come with just like spraying Earth with some microwaves?
Yeah, I was thinking about that too.
Gonna get toasty.
Yeah, I mean, could that possibly contribute to global warming in any way? I mean, we probably don't really know the answer,
Yeah.
but I think that definitely there should be concerns about that.
It's a reasonable question for our audience to consider.
Yes.
Yeah, they even talk about that as well.
Oh, they do?
Yes.
It says you wouldn't even be able to see the radio beam with the naked eye, and radio signals are flowing around. These specific radio signals are going to contain more energy than an AM or FM signal that you normally pick up in your car would. But the power density of the signal would be really low and threaten people or airplanes or birds.
Okay. Well,
All
I'm
right.
sold.
Yeah, actually, that since Casey was talking about what's the most ideal energy source, I think that honestly, if that were to work efficiently and also like be able to be sustainable, honestly, like in terms of cost and in terms of like long-term like ideals, like being able to have it last for a long time, especially in outer space, I don't think that'll be an extreme concern. But I think that if that were to last a long time, that would be a very good energy source. I also think that nuclear power plants, if they were to be refined and if the waste were to be treated correctly, I think that those could also contribute to being close to an ideal energy source, as they don't really produce very much waste. And if the nuclear waste that they do produce, if that was like handled correctly, then I think it would be definitely a good source of energy that I think a lot of the world should be able to use.
Are we talking specifically fusion or fission here?
I was just talking about the ones that are in operation today. Obviously, if the technology is going to progress and it's going to get better, but I think that if fusion were to work, I think we need more evidence that it will be better than what we have right now. But if it were to work and be better than what we have right now, then I'm sure that a lot of people would also accept that. Another risk with that is that people are probably also going to be scared. Anything with like nuclear things, people get frightened of explosions like the kinds we've had in the past. And I think that maybe fear might be a factor, but I'm pretty sure that we can mitigate that if it's safe and if we handle the waste correctly.
Yeah, and even if we got fusion to work, there'd be significantly less waste and like close to none, basically, from my understanding. And there's no meltdowns with fusion, right? Because there's no overheating rods.
Yeah,
Right.
I mean, people talk about like fusion, like if we can get it to work, like it would be the ideal energy source. So obviously that is going to be like my ideal if it can happen. But I mean, I know a lot of people disagree on this, but I actually think wind energy is a pretty, I mean, like it's super cost efficient once you install the wind turbines. I mean, if you spend a bunch of money, costs a bunch of money at first, but to keep the wind turbines in operation, it costs next to nothing, and it still gets you the energy. So I mean, if we make the investment now, we'll be solid on energy for a very, very long time. And I mean, there always is the problem of noise pollution, but I heard about a suggestion of wind turbines near the ocean where they'll be far away from human beings and the noise pollution won't affect them. And it'll also be more winds, which will boost, I guess, the effectiveness of these. Obviously, there's still the problem that they might endanger the wildlife there, but...
Yeah, what do you think about putting wind turbines like out at sea, like where they have oil rigs and stuff? It's obviously possible to build structures out there.
Yeah.
Do you think that that is beneficial? Because again, there's like no visual pollution because people won't see them. There aren't very many birds because it's way out at sea. And the only danger to to fish is that they'll crash into the base of it, which, I mean, how they're going to treat it just like a piece of rock.
Exactly.
Yeah, I mean,
I wouldn't disagree on the premise that wind energy is going to be our long-term sustainable solution. Because I would think solar is a good argument, because once we have something like once we have like solar panels in space, that's essentially like infinite energy, because we're talking about the sun here, which will last for billions of years. So this is essentially, by effect, infinite energy if we do pull it off. However, I think you're right in terms of, if we're talking about now, I think the most realistic solution would have to be something like nuclear fission being treated better, or wind.
Ian?
I like the idea of wind and all. I think mainly from more realistic, hydroelectric might be more realistic than wind would be.
What do you...
What were you going to say?
Oh, I was just going to say, what do you think about the environmental concerns of hydro? Like, especially that on fish and then the surrounding like area, the river banks and etc.
Because like I know it can like displace wildlife and all, but they also have like Bonneville has like the salmon ladders and all the fish ladders. So like there are ways to kind of get around the wildlife, or have the wildlife like move around. Dam, I guess, is a more accurate statement. I mean, like I think it's also just more realistic in general because people are more open to it. Usually, there's less of like visual or noise pollution, really. And like even now here in Portland, we use Bonneville, so more people are using hydro than wind currently.
Yeah, but there's a concern of just how many dams could you really put, there's not. I feel like there's not enough. It'd be very difficult to find a specific piece of land that you can build a dam on, let alone, I don't know, like just finding a property that people are willing to sell you to build a dam. I wouldn't say it's more realistic in terms of the fact that it's going to be our primary energy source, or not primary, but what we're going to use for the rest of our lifetime.
Because the thing with those is they are very situational. Here in the Northwest, we have a lot of rivers, we have a lot of places to put them. But say places in the middle of the U.S., I'm pretty sure they don't have the same luxury So how would you go about fueling or providing energy to places like that?
I'd probably rely on either solar or wind for that, I guess. I mean, like, nuclear is, like, the energy output is really great and all, but we're eventually going to run out of places to store all the waste.
Yeah, and I mean, nuclear fusion is technically still not a renewable resource. We're using a limited resource.
Yeah, but it's very abundant though.
And also,
Yeah.
like, it takes next to nothing to pretty much make nuclear power. Like, the amounts they use. I mean, obviously it has to be enriched, but the amounts they use are so small compared to the, like, output if you compare it to something else like coal or biogas.
All right. Well, I think we've had enough time on this topic. I mean, we spent almost half an hour on it. I think we should try to move on to the particle physics subject. But do you guys want to do the try not to laugh?
Yes, I am down.
Sure.
Totally down for
All
that.
right.
Anyone want to start with a joke?
I can start with one.
Okay, go. Okay, so we cannot laugh at all. Like, I mean, that's like kind of the point. So
All right, let's go.
Yeah, that and, like, just consider this fuel for next year, Mr. Bob, for all your new SL and HL students, I guess.
Gotta have a repertoire of puns.
Yeah.
let's go. All right, let's do it. No laughing.
What do you get across a physicist or rock climber?
What?
You can't. A rock climber is a scalar.
Oh,
That almost made
I
me
get
laugh.
it.
That almost made me laugh. All right, keep going.
I almost left.
You got another one?
Oh, I have so many physics jokes right here.
Hit me with it.
Let's say my physics professor said I had potential. Then he pushed me off a building.
That is just
Do it.
Jack, that
not
almost made me
appropriate.
laugh, honestly.
I don't even know why that's so funny. That's just messed up, man. Come on.
All right, guys. Wait, I have one. A proton checks into a hotel when the bellhop asks, "Would you like help with your luggage?" The photon replies, "I don't have any. I always travel light."
Ah, that's really funny. That's like legit cringe. What? All right. Can we get a better one?
Sorry, Casey, do you have any jokes?
No, not really. I'm not that kind of a jokester.
All right, let's do one more.
Let's do one
All right,
more.
wait.
This time, try to make
Ian,
it
do you want to
better.
do it? Yeah, Ian, you should do it.
I'm sure I can, you know. You know that home is where your displacement is zero.
That's very true.
Wait, I have one more. This is very similar to a joke I told earlier, but I don't
All
care.
right.
Heisenberg was driving down the freeway when a cop stopped him. The cop looks at Heisenberg and says, "Sir, do you realize you were going 75 in a 55?" Heisenberg looks at him and replies, "Great, now I'm lost."
Okay, I got one more
All right, last
before
one.
we end this off. What did the nuclear physicist have for lunch?
What?
Fission chips.
Ah.
What did? Wait, one more. Sorry.
hey,
This is actually the last one.
Okay.
Wait. No. Okay. A neutron walks into a bar and asks, "How much for a drink?" The bartender replies, "For you, no charge."
Ah. Nice one.
Yeah, I've heard that one before.
That's
yeah,
a
we
good
did that
one.
one in class. That was the
I'm
riddle
sorry.
solved.
Oh,
All right.
true,
Anyway,
true.
that's a good
Yeah.
segue on to particle physics, by the way.
Hey, y'all know me.
All right,
All right.
let's go into our next topic, particle physics. Woohoo, man.
Yeah.
All right. What do you guys think about particles?
Do they exist? Do they not? Do they really matter in our society? What are your thoughts?
Me?
Anybody?
All right. Well, I want to say something. I don't know a whole lot about particle physics, So I might not be saying that much during this
No worries.
subject.
I think with particle physics, it's interesting that I think the first part is that when we even first discovered like that there are atoms per se, like there are little things that make up all matter in the universe, and then we discover that there are even, I guess, there are subatomic particles to that, which is pretty crazy. Like the fact that we have like quarks, and that there's 6 specific one that they have identified.
Okay, well, I mean, this question is kind of a little bit unrelated, but I think it's kind of an important question that's kind of pretty thought-provoking. It's that, like, when you look at dark matter, and we'll talk about that more later on the podcast during Astro, but people say that dark matter it's non-baryonic matter. Does that mean that it's not made up of quarks? In which case, what would it be made up of?
Yes, if it's non-baryonic, I believe that suggests that it's not some kind of particle.
Okay.
I mean, we know for sure that it does exist, but we'll get onto that later. But if it's classified as non-baryonic, that means we can't detect it. That was kind of the major concern with dark matter, is that we can't see it or detect it in any way. We just know how it affects other objects.
Yeah, and going off of that, do you guys feel comfortable like knowing that there's stuff that you can't like see or detect at all, and does that bother you at all? Because for me, it just seems kind of weird and doesn't make sense.
Yeah, I definitely agree with Thomas on this one. When I mean, like, if you think about it, like, I was super skeptical of dark matter until I heard that there were, like, many, many recent things that absolutely almost solidify the proof of this stuff. But it just seems like when I first heard about it that there was just this, like, one thing, and they're like, oh, our laws don't account for this thing that's happening. You know, why are the outsides of galaxies spinning faster than the middles, or than they should be? I mean, like, that was one of the most, I guess, convincing proofs of dark matter's existence at first. And like, when you think about it from the perspective of, it's just like, oh, we can't explain this with our physics, so we're going to invent this magical thing that we can't see, but is there, that is actually matter, and that explains it, so that our laws still work.
Yeah, I think just particles would relate kind of to dark matter, kind of the fact that there are these little things that, I mean, yes, we can detect it, but it's just so bizarre. Like, I think with the recent, obviously, with discovery of like the proton, neutron, electron that we've discovered since like, the 1800s, it's been pretty solidified. People like know about it. It's not that bizarre, even though, it's these tiny particles that make up all of the universe. And then now we've been, since like the 90s and 2000s, we have discovered quarks, things that are smaller than protons and neutrons that make those up, which I think that's a little weird as well. Like, is there even smaller particles that make these quarks? I don't know.
Yeah, also, something that I've been, like, that's kind of interesting, it's kind of a philosophical question about the way we view our world. Do you think that, and I'm not saying that our current laws are wrong or anything, but it's just kind of interesting to think about. Do you think we should, like, adapt our rules to, like, the world we see when we detect something new? Or should we even consider trying to redesign the whole way that we see things to make it fit the new thing, instead of just trying to edit what we already have? Do you think that it's better to go back and kind of reinvent the things that like go off what we know for sure, and then kind of reinvent the unknown?
I think that's what we've always been doing with physics. We've always been proven wrong about things because it defies our senses. Like the fact that certain, like, I don't know, the idea of like objects with different mass can fall the same, fall at the same time. Like, that just seems so incorrect. You know what I mean?
Yeah. Well, I am going to answer this question by asking you guys to go ahead and think about all the times, that we have been wrong in the past. And every time it seems that it is better to go ahead, look back and say, okay, this doesn't fit with our model. Maybe that's a problem with our model and not with this thing. You look at quantum mechanics, and it turns out that basically every single law about movement that we have is actually not exactly precise, and that things actually follow these very, very slightly different, mechanical laws. Yeah, rules. So, it seems it definitely is a lot better to go ahead and take a step back and think, well, maybe this law is not correct.
Yeah, I think that's just by nature of the scientific process, right? We're trying to get rid of the human error in as many ways as we can so that we're not, obscuring things that seem so contradictory to what we think is correct. I don't know. Ian, what do you think?
Well, actually, before he says anything, there's one more thing I want to add to this. It's that I watched this really interesting video about how there's always going to be error in whatever you measure. Like, you can get that error down to micrometers or the tiniest increment, but you can never know anything with 100% certainty because there's always going to be error. And I think that if you get on the really small scale, if you're searching for something, and even though there's a small error, you see something and you observe it, it's still possible that your positive result could have been a result of your error, and that it's just a mistake.
That's pretty insane. Quite mind-boggling. Because it seems like with the micrometers, with big objects, it's pretty much negligible. But with smaller objects that we will discover, if we don't get to kind of that level of measurement where it's essentially negligible, the error, I think a good point to make is new particles that we discovered through hadron colliders.
Oh yeah.
How do you even classify all these particles, you know?
Yeah, that's something that's really interesting to me. Just the way that, going back to what I was saying before, it seems amazing that we can even make stuff fit into our current model. And the way that we do that is just really interesting, and honestly, I think it's rather impressive.
Yeah. I don't know.
I can't think about the Hadron Collider without thinking about that song that Mr. Bob showed us.
Yeah.
That's so catchy.
Quick question, though. If you had your very own Hadron Collider, what would you first?
Wait, can you repeat that?
If you had your very own Hadron Collider, what would be the first thing you want to, squish or, smash up?
Smash?
It doesn't have to be a particle. What would you use?
I would probably collide.
That's interesting,
Casey.
actually.
I'd probably smash Casey.
No, that's really interesting, actually, because I guess it comes down to what question do you want answered, sooner, really.
Yeah, when we finally discovered the quote unquote the particle that kind of fits the Higgs boson criteria, that was pretty groundbreaking. But I guess we haven't really seen any news about anything quite interesting about particle physics, other than from what I've seen, China has been trying to make a lot of hadron colliders that supposedly are much bigger than the one in Switzerland.
Oh wow!
It's I believe the current one is 27. Is it meters or kilometers?
I'm gonna think. I don't know. 27 kilometers seems kind of big, but
Yeah,
I
I
really don't
think-
know a lot about.
I think
the
that's
scale.
more likely because these things have to accelerate the particles pretty fast.
Yeah, someone could check that, but China has already proposed 2 that are 3 times as long as.
Okay, well, I think it's 27 kilometers because yeah. The Large Hadron Collider is the world's largest and most powerful particle collider, the most complex experimental facility ever built, and the largest single machine in the world. It was built by the European Organization for Nuclear Research between 1998 and 2008 in collaboration with over 10,000 scientists and engineers from 100 countries, as well as hundreds of universities and laboratories. It lies in a tunnel 27 kilometers, 17 miles in circumference. So yeah, and that's from Wikipedia.
Okay.
That's crazy.
Yeah, because China's trying to do 100 kilometers, and I've heard they've tried to propose like 2 of them.
Wow.
That's supposed to be like done by 2030.
Yeah, I mean that'd be a lot of work. I mean, like it says, for the Large Hadron Collider, they collaborated with over 10,000 scientists.
And it took 10 years, right?
Yeah, 10 years.
It's kind of crazy how much effort these things actually take to make.
Yeah, but with China though, China has an interesting dynamic of the fact that they pretty much, it's like state control, so they can like, I don't know, if they're really dedicated to this, I think they could finish it in a good amount of time, because it would be like the government and private, companies and like investors and universities, but I wouldn't know if it would be an international collaboration. That would be interesting to consider.
Yeah. Well, while we're still on the subject of particles and such, I mean, I heard that Thomas did not believe in the existence of the graviton.
Well, I never said that. I just said that it's kind of, I find it kind of weird to say that this particle X exists, although we have, it's like a theorized particle, although there's no way to measure it. It has no charge. It has no mass. Like, as a human being who, like, because we've evolved to like make logical decisions and see things, like hold a book in our hand, hold like a, I don't know,
It's
like,
empirical.
touch things.
It's empirical.
Yeah, like how do you know something exists when it has zero mass, zero charge, and it's just like, that just kind of blows my mind.
I think it's just the same idea with dark matter. Like, gravity.
Yeah, but dark matter, we at least like, it has mass. Like, we know it's something is there.
Yeah, but it's just the same idea of like, this thing that we really can't see is affecting us. Like, we can see it. Like, we see the effects of gravity, and we observe the effects of dark matter and dark energy on galaxies and the expansion of the universe. So, I don't know. I think it's just the same kind of question. But that is interesting that it has no mass.
Just sounds like you're kind of getting into some TOK stuff there, Tom.
If the graviton is real, does that mean the Thomas particle is real?
Yeah, I made that joke too many times, but anyway.
I mean, I think we need something to mediate the existence of Thomas. I don't know if he'd be physically. I don't know if he'd
But
obey
does
the
that mean
laws
that
of
every
physics.
person has their own particle?
Oh.
Well, I mean, while it's theoretically possible, I think that are you guys familiar with Occam's razor?
Yes,
I am,
yes.
Yeah, I mean, it's pretty much just applying that there. I don't think every single, like, I think there's a finite amount of particles. I don't think that there's like a billion new particles that do all sorts of tiny different things.
Yeah.
I think that the more simple it is, the more likely it is to happen. Like, I totally believe in that. And I think that, sure, there might be several unknown particles, but I don't think there's hundreds of thousands.
Yeah, I think when we watch that video on like the physicists explaining, like, we only see part of the game, right? We only see parts of the
Richard
rules, right?
Feynman.
Exactly, yeah. We only see parts of the rules, so we will try our best to observe as many times as we can so we can figure out the rules. Right now, we're discovering like several new parts. Like for example, like I didn't even know there's a muon particle or whatever.
Mm-hmm.
Like, I feel like once we discover like all these things and once we figure out like how they relate to each other, then we will eventually simplify it.
Yeah, I agree with that.
So do you think they're just particles that we're never going to discover? Like, well, I mean, not in our lifetime, but like.
Oh boy, that's a hard question.
Ever?
Ian,
Well,
I mean, Ian, you should answer that.
Ian, yeah, you should go on.
Well, I mean, there's a lot of other stuff to take into consideration with that too. Like, how long is the human race going to stay alive, and how, like, is there an extent to which our knowledge can be applied And like, will we ever develop the machinery to understand some of these particles?
Well, have you guys heard of the Fermi paradox?
Yes, I have.
yeah.
That's one of my most. That's one of the things that interests me the most, actually.
Yeah, I mean, like, if in case any of you guys are unfamiliar, it's basically the fact that if you, I mean, this is just kind of a way to explain it. If you consider life on Earth now, and your life as a random sample of human life, I mean, we're born like relatively towards the beginning of, I mean, intelligent life and civilization, and like, if you consider that as a random sample, then it's more likely that the human race will end sooner rather than later. To kind of explain it in a more simple way, say you have a hat, and the hat is either a hat with numbers 1 through 5 in it, or 1 through a million, and you reach into the hat and you pull out the number 2, it's much more likely that the hat is going to be the hat with numbers 1 through 5 rather than the 1 through a million.
Ooh.
And so, and it's also like, I mean, it's basically, I mean, it's kind of a commentary on is the fate of intelligent life just to basically end itself?
Yeah, because
You
like
know?
with Ian's question of like discovering, can we discover all we can before, you know, we all like we just don't exist anymore? Like, I don't know. Just seems kind of bizarre in that manner.
Yeah, and I really think it's hard for us to really understand that, like, as people looking into the future, and like, because the human mind isn't really built to comprehend things like that.
Yeah.
And it's just kind of it's really hard for you to make a prediction about that, but I think that it's really, really interesting to think about and to theorize, because there's definitely the possibility that we will kill ourselves. Like, I'm reading this book talking about how we're killing off all these species of plant and animal, and it's kind of ridiculous how fast we're going. Like, by the year 2050, it said we will have killed off 23% of the species we have now.
Wow.
And like, if that keeps going, we're assuredly going to kill ourselves, right?
But I mean, Thomas, I mean, you look at the history of the Earth and we see countless I mean, not countless. There has been historic extinction events, and the Earth always seems to bounce back from that. I mean, so, and honestly, like, if you look at the Earth and the number of species, if the human race goes extinct, that's just one species gone.
Right.
You know?
Yeah, but
Right,
a lot
that's
of those
exactly what I'm
extinct-
saying.
But we're different.
A lot of
We're different.
like,
in
a
the
lot of
fact-
those
Yeah. You go, Ian.
like a lot of those weren't caused by though. Like
No,
most of it was like kind of natural selection, or like Ice Age. It's like a few I can think of off the hand that were like caused by the dodo or like the thylacine or the Tasmanian tiger because we hunted them all.
Well, I mean, listen, I mean, but the fact of the matter is that human beings evolved from this Earth. Anything that they do is just derivative of the Earth. I mean, the Earth created humans, so anything that humans do to the... I mean, okay, they didn't... the Earth didn't create humans, but humans evolved from life on the Earth. So anything that humans do to the Earth is its natural path.
I would disagree with
That
you.
is just I don't think
Okay,
that's
well, what do you mean?
like, okay, I understand your premise on the fact that like
No,
humans
I mean,
humans
can
are
I hear an argument from the other side? Because I don't see any like reason why that would not be true.
because the reason why humans are so different is that we are actually basically the we are handling the environment with our own hands here, because as Ian said, the previous mass extinctions have been all naturally caused. Meteorites, from the dinosaurs has been proposed. Ice Age. Well, what we're doing right now is so different because it's what we're doing.
I mean, surely it is
And
different,
and
we are animals that are doing things that are natural. I mean, it is not normal for a meteorite to hit the Earth. It is not normal for a species to evolve that creates things that kill other species, but it is the natural course of the Earth.
I would
All right,
agree
I
that
see
it's
that.
not
That's
normal.
fair.
I would agree that it's not normal, but we can control what we're
No,
doing.
we can.
That's right.
I'm not saying we should just go ahead and screw up everything because it's the natural course of the Earth. I'm just saying, I mean, obviously we should do whatever we can to protect our planet and to protect the species on it. But when you look at it from a neutral standpoint, if humans do inevitably kill a bunch of species, that is just another natural extinction event in our history.
Right, and
But
so
it's
going.
not natural if it's man.
Yeah, I think we're
But
going.
what lens are you viewing man from that makes them any different from any other animals? We are just animals on this planet.
Well, okay, I think that at the end of that discussion, what it really comes back to is the original question of, are we going to make ourselves go extinct? Because that was the whole beginning of this whole discussion. Like, are we going to survive long enough to discover all these particles?
Well, I think we should make ourselves extinct.
Okay. I think we went on a huge tangent there, but that's okay.
Yeah.
I think let's just kind of finish up particle physics in general. Just
I got one article with you guys if you want through it. I guess it's about anti-hydrogen and the spectral lines from the different energy states.
Oh yes.
And basically, what they were saying, it's pretty long, so I didn't really read the entire thing. I a bit, but they're saying it matches what we expected, in that being it's very similar to hydrogen. So we're thinking that it just confirms the whole antiparticles act like the real, not really the non-anti particles.
Yeah.
so we act in that
the
manner.
normal particles. The anti particles. The particles that the anti-particles coincide with.
Yes.
Sure.
Yeah, dude. I mean, what is it trying to suggest about particles in general?
Well, I mean, it's
It's just confirming what we thought about, or what we knew already, or what we guessed, I guess.
wait. Okay. This is just a question about antiparticles in general and antimatter, I guess, in general. But I mean, I never really understood the whole thing of where all the antimatter went in the universe. Do any of you guys have a reasonable explanation for that?
Just from
I'm
what?
pretty sure. Yeah. Or here, you go, Kate.
No, you go, Ian. You can explain it.
I mean, I was pretty sure. We did that whole podcast, or the podcast we listened to. And, we don't know because theoretically, every particle has its antiparticle, and then when they come together, they collide. We're missing a bunch of antimatter in our galaxy, which is the only reason why we're here in the first place.
Right.
Right. Yeah. Exactly. The fact that if the premise of that for each particle there's an antiparticle, we should all be gone. Right. Because
Except we're
yeah.
Or
So we're here.
Yes.
But we're not gone.
Yeah. Exactly.
yeah, so we don't know what happened to it.
And
To all this.
But here's the thing, though. It's just so bizarre that these things that are, I guess you can, lack of a better word, opposite of us. The fact that we know about these things that can, when colliding with their, matter, their opposite self, that they collide and essentially destroy themselves. So it's just bizarre that such a concept can exist.
Yeah.
Because it suggests that, we shouldn't even be here.
To answer your question, your original question, we don't know.
We don't know. Okay.
Yeah.
Could it potentially
Probably.
be that there's another world that's just full of our antimatter?
Whoa.
You mean you're getting into parallel universes now?
Yeah.
No, it's
Yeah,
wait. It's there's an anti-Earth where anti-Jack and anti-Ian and anti-Casey and anti-Thomas are recording this podcast, and they think we're the antimatter.
Yeah, but the interesting thing with that is, I just thought of this randomly, and this might be completely wrong, but we don't have to assume that it's going to take the exact same form. The components don't have to assemble in the exact same way.
Right, and that's also bizarre, too. That there's just this whole new mechanic, potentially.
Right.
Well, it wouldn't be antimatter then, right? Because the antiparticle has the same mass characteristics usually as
like the non-antiparticles, so, you know, with like minor differences, so like the spin,
Yeah.
magnetic spin's different.
They're actually, I'm reading now about there are slight differences. Just this website, I guess it's from CERN, which is CERN, which is the like kind of like the national science thing. But it says they found that matter and antimatter particles decay at slightly different rates, and that some matter and antimatter particles can spontaneously transform into their matter and antimatter counterparts, which just seems bizarre to me.
That is just really weird, actually.
Yeah, that reminds me of like quantum tunneling and all that stuff. Just like how they can randomly do things that are completely unexpected.
Like go through stuff.
Yeah.
And it only works with like very, very like electrons. Like it's more common in electrons than protons because electrons are smaller.
Yeah.
Mm-hmm.
That just.
All right.
I mean,
you guys want to move on to Astro?
yeah, I think there's a good segue into kind of talking about planets and stuff.
No, we have test our knowledge, guys.
We gotta test our knowledge on what?
Are we doing the riddles?
Attempt to solve physics riddles and transition to next topic. Oh, wasn't supposed to read that last one. Does anyone have any physics riddles?
I think I have a couple. Okay.
I got 6 extremely hard math and physics riddles right here.
Oh no.
Bring it.
Okay, there are answers. Sure. So you're in a cement room with no windows or doors. The only thing you have with you is a mirror and a piece of wood. How do you get out? Actually, I've heard this one before, I think.
Wait. Can you repeat that?
Oh, I know this one. I know the answer to that, I think.
No, okay, no, that's not physics, really.
Yeah.
Wait, I have an answer.
Yeah.
You get the antimatter to the walls, and you force it to collide with the walls, and they explode.
I think that's a valid answer.
Oh no, I'm just gonna quantum
that
tunnel
makes it more
through
physics
it.
related than this thing.
I'm just gonna quantum tunnel through the wall.
What is the answer? Oh, true, Casey.
It's one of those answers where it's like you look in the mirror and you see what you saw. You take that saw and cut the piece of wood in half. Put the two halves together to make a hole, and then you crawl out through that hole.
That is literally. I hate those so much.
No, actually, I like Casey's answer. You run into the wall and pray that quantum tunneling works. The small probability that you can get through the wall. And
Oh, you know what? Okay. Even though we're kind of going back into discussion, like, how about the fact that could we potentially amplify like the usage of quantum tunneling to like the human level?
no.
I feel like that'd just be so weird to be able to do. Like
Uh,
manipulate
yeah,
quantum tunneling. So
Well, I just think it's like it's a law of physics that happens, but like we can't influence. It's just very, very unlikely.
yeah, I don't know.
Yeah,
I think we should move on to astrophysics here.
Yeah, let's just try to end it out.
All
Okay,
right.
it's our last but not least subject. It's astrophysics. Are you guys ready?
Absolutely. So,
You
guys,
seem like you quit on these riddles already.
Yeah, dude. Come on, they're lame.
Riddles?
and give me one more riddle.
Yeah, give me a riddle.
Oh man. Here we go. This is actually like physics questions. Woohoo.
Okay, go.
Which type of transmission uses the shortest waves?
No.
A wire? I don't know.
No. Wait. I don't know, what is it, Ian?
It's satellite TV.
True.
It uses the microwave, or it's microwave.
Yeah.
Oh, I see.
Interesting. All right, so
E, you got another one before we move on?
Oh, I got a whole page on it. On.
Okay, well, you better read one more because I think we gotta move on pretty quickly.
Oh yeah. Go. Who discovered radioactivity?
Mary Curie.
Yeah.
Oh, really?
Yes.
That's
didn't know
not what it says here.
Dang.
It says here it's Henry Becquerel.
Oh, that makes sense because like the radioactive.
Oh no! Yeah, I think Marie Curie did something else that was related.
She did radium, I think.
Yeah, she did.
Yeah.
She discovered radium, but not radioactivity.
No, he worked alongside Marie Curie.
Oh,
Wait, guys, I know this is kind of not related because this is kind of about chemistry. But do you ever realize like that the laws of chemistry sometimes don't like follow like aren't actually as precise as some of the laws of physics. Like the further you go down like the noble gases like column, I guess. Like I mean like I think number 118, which is oganesson, I'm pretty sure it doesn't behave like a noble gas, even though it's in the column. Maybe I'm thinking of, I think it used to be called unindinium.
yeah.
I don't even know, like
Chemistry has always been that, because like even in chemistry they tell us like electrons have no mass, which we all know is false.
Yeah.
I think
I
it's
think that's just for ease, though.
yeah. That's
I mean,
what,
like in the precise atomic masses,
yeah. Same
they
thing.
don't assume.
That logic of like for convenience, the periodic table is kind of set up so that it's based on the amount of protons an element has, and obviously there are trends in that periodic table, but you can't say like there are obviously exceptions to all these trends. I feel like we already know that.
Yeah.
Yeah.
All right. Well, that was a tangent.
Let's just go on.
Guys,
Let's just go on to astrophysics. Does anyone want to start something off?
Yeah. So I was talking about dark matter, but this is just kind of food for thought, I guess. But I have this article up from Science Daily titled "A Cosmic Gorilla Effect Could Blind the Detection of Aliens," and it's based on an experiment with young people bouncing a ball, and it shows that when an observer focuses on counting the number of passes, he does not detect if someone crosses the stage disguised as a gorilla. So the idea is when we're looking for signals from extraterrestrial beings and we're assuming that their signals would be similar to our signals as humans, and we're kind of ignoring intelligent non-earthly signals, which might manifest themselves in dimensions that escape our perception, such as the unknown dark matter and energy.
Wow. That is...
Yeah, if the dark energy is the aliens and they're trying to pull us towards
I don't know,
They're
like...
trying to pull themselves apart from us.
I don't know how to
That's why
think
they're-
about that seriously, though, because, like... I don't know, I think that's just...
Well, I think thinking of dark matter and energy as something that aliens are doing, like Thomas mentioned earlier, Occam's razor just kind of tears that to shreds.
Yeah,
But
because I feel like with aliens, like, if they know that we exist or that other life forms exist, why wouldn't they use a simplified, like, way of, of sending signals, like,
yeah,
Well-
well, I mean, Thomas, go ahead.
Talking about aliens is like incredibly complex because first of all, we don't know if they have the technology
Right.
to broadcast the type of signals that we do.
And-
Their
and-
resources might be completely different. Secondly,
Yes.
like they might be blindly sending out signals hoping for a response. Like they don't have to know we're here.
Yeah.
No,
and,
I'm not saying they know we're here. I'm just saying that if they have that self-consciousness of, like, us humans, then they would realize, like, hey, we should probably send... Oh, well, I guess you're not. I think you would be right.
And we also have no context as to how evolution or even a life in general would happen on a planet that wasn't Earth, because we have not seen a single example of it. So we have no clue what these aliens would be like. And if not only do we not have proof of intelligent life, we don't have proof of any life on another planet. You
That's
know?
true.
Not
Ian,
even...
were you going to say something?
I mean, like, it makes sense. Like, it's pretty natural to not really grasp this thing because it is a paradox. Aha, well, I don't know how physics related this is, but this is something that I ended up having to study for a very long time, or a few weeks, really, which felt a lot longer. But it was there's this specific company that's trying to build a space hotel.
Oh
Have
yeah.
it into low Earth orbit by the year 2022, so they want to have it fully operational by that time.
Yeah,
So,
you've heard my views on that. I think that's completely ridiculous in terms of like there's several reasons why. The first is 2022. That's in like 4 years. That's not happening in my opinion. Secondly, that's extremely like expensive. How the heck are they going to get people to actually like get them up there? How are they going to like that it's going to have to cost several hundred, like it's going to cost like $80,000 to get them up there really like per person.
Well, yeah, like the specific price is it's an $80,000 down payment.
Yeah,
Plus an additional
that's absurd. who would
$5 million for every person that you want to go up with you, and you can only have like 4 additional people or 4 people go up at a time.
Also,
So I think this is intended for like people like Elon Musk or like other multi-millionaires who are like, well, I might as well. You know, I don't think this is for the everyday citizen such as you and me.
Yeah, I don't think this definitely relates to anything astrophysics like.
I don't know. It's just a little interesting topic, I guess.
Yeah.
Before we fully transition onto the next thing.
I don't know.
I think
I think another bizarre thing I've known for quite a while is like the fact that Saturn's ring will just be like gone.
what?
Yeah.
Well,
are the rings fading or something?
Yeah,
I
like
have not
the
heard about
rings will
this.
like eventually just not exist like over the course of millions of years because I think it's because of like Saturn's like gravitational attraction where it'll just get all these
sorry.
rings. Because the rings are just like asteroids, no? Technically, or like
Yeah, they're rocks and ice and stuff.
yeah. It'd just be weird, right? Because like we've known all our life that Saturn is the planet with the rings, but it's just the fact that it's gonna be gone. It just would look like it would just look so bizarre. I don't know.
Yeah, what's interesting about that is you said that it would take a long time, and I totally believe that it's gonna take a long time. So I think by the time, like, if we're even still alive, because I'm pretty sure it'll take a couple million years at least.
Like
Like, by
hundreds.
the time-
yeah.
Yeah, but by the time that's done, if we're still here, I don't think there's gonna be any record of the rings like really existing.
Well, I think there might be. Okay, here's another thing that will happen in quite a long time. I don't know how long it is, but I saw this Vsauce video that was basically about what we will miss in the history of our lives, and it eventually goes up to, you know, when the sun will inevitably supernova, and we will like the Earth will. But it said, I mean, I don't know if it was. So in the in like a million years, like since the Andromeda Galaxy is coming towards the Milky Way, you'll be able to see the Andromeda Galaxy like in the sky, like it'll fill up the whole sky for like thousands and thousands of years.
That is just
That's crazy.
hella weird. That sounds kind of scary though.
Yeah, I mean,
Ian?
Oh yeah, no, I was just gonna say it's very quick little tangent. But like I first found out about the whole Andromeda Galaxy colliding with the Milky Way when I was very, very young, about like 4 or 5. I did not know what was happening in a few million years. And I was very freaked out.
What the fuck? Okay. Oh, you know what?
I think it's really cool.
no, it'll be awesome. I mean, if humans are still alive, that,
You know what's also super relatable? Like when you're young and you're just like driving, like your parents are driving your car and you're like, the moon is following me.
I think you're the only one who thought that.
No, like obviously you know that the moon is not following you, but it looks like
I hear what you're saying, man. Alright,
Okay.
anyways, back on astrophysics.
Yeah, I'm sorry about that.
You guys want to talk about black holes?
Oh yeah, dude.
That's a really interesting topic.
I don't even know what to think about black holes other than
I mean, like,
yeah.
what particular subject on black holes were you thinking of talking about?
I think the
Okay. Casey, you want to go?
yeah, just like the weird like super massive black hole in like the middle of the galaxy, like that just sounds so scary because you would think like it would just suck in like all of the matter around it if it's that huge. I mean, obviously,
didn't we talk about that though? Like, don't all galaxies have a massive black hole, or just some black hole in their center?
yeah.
Like, all.
Mm-hmm.
Well, like again, like what we said, it doesn't have like the gravitational pull inside of it, but it's got like gravity that causes the orbit around it.
Oh yeah.
Oh yeah.
So like nothing's actually like really pulled into a black hole, right? Except for light,
Yeah. Well, I mean,
or light doesn't go like once it goes in, it never comes out.
yeah, it never. Well, once anything goes in, it
Well,
never-
yeah. Because what happens in a black hole stays in a black hole.
Hey, my man.
What?
Yeah, no, well, I think it's particularly interesting is the fact that Einstein, I mean, this is just like in general about physics, like we were talking about how like people like change their rules because they don't believe that something could possibly happen. I mean, Einstein had his laws about matter, and they allowed for the existence of black holes, but even he himself could not conceptualize black holes actually being real.
Even though his calculations would predict
Yeah,
such a...
even though his calculations like proved that they could be real.
Well, not really prove, but suggest that.
Yeah, what? Yes, I mean we're fairly sure that black holes are real.
Well, haven't we observed them?
Yeah,
Like, we've seen like darker spots in a dark
and then
place.
like we also saw the when they rotated around, or like when orbited around each other, when they orbited around a partner star, right?
Yes. And I mean, when the LIGO picked up, LIGO, of course, is the wave, our gravitational wave detector, picked up gravitational waves from millions of years ago from two black holes colliding.
Yeah.
Yeah.
So we are pretty sure that
Black holes exist.
Yeah.
Nothing really on the top. Oh, also like like wormholes. Apparently
Yes,
that's
I've
just
heard of
becoming apparently that's just becoming more science fiction like
Mhm.
it's not there hasn't been really any proof or really any real suggestion that there could potentially be some kind of wormhole mechanic.
Yeah.
Through black
I mean,
holes.
I don't know. Like, I remember hearing about those in elementary school too, and they were pretty much taught to us as a fact.
really?
Were they? Really?
They
That's
could exist in some way, but like,
Yeah.
it's just interesting how that changed. So, like, I don't know. I don't want to say drastically, but it changed a lot in the relatively years.
Yeah. I think the only real basis for the wormhole argument, I mean, maybe there's more of a basis that I don't know about, is the fact that we don't know what happens to matter when it goes into a black hole. And the law of conservation of matter suggests that it can't just be destroyed. So, I mean, there is a theory that it is transported to another part of the universe, or like, I mean,
right.
Yeah, we have no real way of testing it unless we somehow until our civilization really progresses it.
Yeah.
Yeah.
And that's
While
very, very far away.
Yeah. While we're on the topic of like black holes, I want to like shift the conversation to cosmology, and like also about the origin of the universe, because the Big Bang is like that's something that really interests me, and I've heard theories about like how the Big Bang was just like one of many, and like the universe just like shrinks down to like a single point and then expands again, and then it like shrinks down back down.
I've seen
And I
heard
think
of that.
that's a really interesting idea, and I want to know what you guys think about that.
Jack, you want to go on this?
Yeah, I mean, I'm inclined to believe that that is not the case, just because we have observed the expansion of the universe to be accelerating rather than slowing down. I mean, if we observed the expansion of the universe to be slowing down, then I could reasonably see how it could expand to a certain point and then contract. But because, I mean, unless like, I mean, I know we joke about this stuff sometimes, but I mean, unless the derivative of the acceleration or the jerk is if that is negative, or if if the derivative of the jerk is negative, so the rate at which it's okay.
The acceleration of the acceleration.
Yeah. No, wait, it's
Alright.
just accelerating, my bad. So if the jerk is negative and the rate of acceleration, although it's accelerating, if that is slowing down, and then eventually it starts contracting in on itself. I guess I could see that as a possibility. I just don't really know the basis for that argument, other than the fact that it could happen.
Because there's
Right.
multiple theories, and like, especially considering like black holes, like the theory of like the end of the universe. Like, there's like the theory where like basically, our universe just becomes like a pool of just black holes that eventually just decay, and then it's just everything is cold and sad.
Yeah.
Like, where there's where there's like the fact that the universe expands to the point where everything is so far apart that
The deep freeze, yeah.
the deep freeze.
Yeah. Heat death.
Then
That's
there's
the other one.
there's one where Thomas suggests where somehow gravity eventually wins the battle against dark matter, and the universe recontracts, and so the universe exponentially heats up, where we just essentially all melt, I guess, per se.
Yeah.
Yeah,
So
Oh, go, Jack, if you want. But I have something really interesting.
okay, go ahead, Thomas, because I just...
Yeah. So we talked about if gravity was too weak or too strong. What do you think would happen if gravity was just right?
What do you mean just right?
Like I know if gravity's too strong, it'll overpower the expansion of the universe and it'll shrink back together. If it's too weak, it'll be the deep freeze thing, right? Everything will grow cold. What do you think if gravity is just strong enough to bring the universe to a stationary thing where it's not expanding, not contracting, and just like is in a state of equilibrium?
That is
Would that
wow.
function? I think that would function.
I mean, wouldn't that just mean it's not moving at all? If it, there'd be an equal. So, that would be in my mind, that would mean that the gravity lose the dark energy, right? If it's in equilibrium, and it wouldn't be moving at all, right? It'd be two equal forces opposing each other.
Right.
Yeah, they have the same magnitude of force.
Yeah, so I'm here on the Wikipedia page for theories about the end of the universe, the big freeze or the heat death. There's the big rip, which I'm gonna read. Okay, let me just read the Wikipedia quote because I don't understand this one. In the special case of phantom dark energy, which has even more negative pressure than a simple cosmological constant, the density of dark energy increases with time, causing the rate of acceleration to increase, leading to a steady increase in the Hubble constant. As a result, all material objects in the universe, starting with galaxies and eventually, in a finite time, all forms, no matter how small, will disintegrate into unbound elementary particles and radiation, ripped apart by the phantom energy force and shooting apart from each other. The end state of the universe is a singularity, as the dark energy density and expansion rate becomes infinite.
Oh,
And
That's
then
interesting.
I think
there's the big crunch, which is when the universe obviously contracts into itself. There's the big bounce, and there's the big bounce, which is saying that the Big Bang will happen, the big crunch will happen, Big Bang will happen again, and that continues.
Right, that's like
the rest of
Thomas's
the
theory, where like the universe expands, contract again, then re-expand, contract, kind of like that.
Right.
I don't know. It's people have, I don't know, not definitively said, but like I think most people who think about these like endings of the universe, most would say that heat death is the most likely.
Mm-hmm.
The big rip one is really weird.
Yeah, I think that's saying though if
It's saying like
it's just saying. Okay, I actually don't understand it.
it's like the density of dark matter increases with time, so eventually
leading the Hubble constant to increase.
Yeah, and then eventually
Maybe that's why no one can agree on its value.
Yeah,
Yeah, you know it.
I feel like
Is every new value increasing?
okay.
I don't know.
I think let's go on to I guess like two more things. Like one thing that could be interesting is the like planetary systems, like
exoplanets.
Yeah, exoplanets, and that we've discovered like a good amount of exoplanets too, and that we haven't found any kind of evidence that there's life, and like the conditions of planetary life too.
I mean, are we specifically looking for carbon-based life, or like, like us, or are we looking for all types?
But like just like
But before we hop into this new topic, I want to suggest one alternate theory for the end of the universe. I call this the Casey model for the universe, and it's that if Casey's existence continues for too long, the universe will be unable to bear the burden of
Oh god,
sustaining Casey, and will collapse in on itself in order to prevent Casey from existing.
the Casey singularity.
All right. Anyway, exoplanets and life on exoplanets.
Yeah, I just like we know about like the Goldilocks like zone, like where a planet has to be like a certain. But I definitely think there are more factors than that, right?
Well, I mean, you'd think if that was the only factor, then we would have discovered life.
Right, but that's like what we've been taught, you know.
Yeah.
Even that, you still hear like pretty like I don't know, like it's not too common for like new news to come out that says like, oh hey, we found another potentially habitable planet in another Goldilocks zone in some other galaxy that's a few hundred light years away, a few thousand light years away.
Yeah, exactly.
Right.
Like what are other factors that contribute to like what we think is a habitable exoplanet?
Well, what I think there are plenty of planets that are habitable, but just the very specific processes that the planets need to undergo in order for life to, I guess, like, be birthed or to be like to begin, just haven't been carried out on those planets that we've discovered yet.
Yeah,
I mean, I think. Go ahead,
Yeah,
guys. Yeah.
Okay.
Thomas, you just go.
All right. Yeah. As he was saying, it's basically like, you know how evolution is mostly random chance. Mutation is mostly random chance. Like the spontaneous creation, which is, I'm pretty sure what, like how we believe that life first formed on Earth. I think that is something that's incredibly rare, and for that to happen somewhere else, you'd need the perfect conditions. And even if you had the perfect conditions, it's not guaranteed that it would happen.
And this all kind of relates back to that gorilla effect, too, right? Because that's just assuming that we'd be able to comprehend or understand the forms of life on a different planet. So we're basing it off of our own. So maybe we're just looking for the wrong signs entirely and miss like actual other life, you know?
Mm-hmm.
Okay, let's kind of just because when I think of like factors that contribute to like a workable planetary system is like the fact that we have Jupiter, right? Because like there's a bunch of meteors that fly around, and if we don't have a planet like Jupiter, then we wouldn't even exist because we'd be bombarded by meteorites at the point.
Right.
I think we can end it off here.
All right. It was a pleasure sharing this. Whoa, almost an hour and a half with you guys.
Yeah, thanks.
Talking about physiques.
Physiques.
What we think of them.
These are some physiques.
Yeah,
No,
I think it was great, like going through all the different types of things that we've learned this year, like energy sources and particle physics, and especially like the kind of sidetrack things that we went on. So like talking about aliens and then also habitable planets. I think that those were topics that were not touched upon very much in actual physics class, and I think it's great to explore those with you guys.
All right.
Absolutely.
Yeah.
We'll see you guys next time.
All right, bye.
Bye.
So long.
Oh, I love physics so much. I really love physics. Yeah!